Let's resume our second part of our session. So it's our pleasure to have Maria Grazia Viola from Lakehead University. Grazia is going to talk about a nuclear dimension of twisted groupoid CSR algebras.
Thank you. So thank you for giving me the opportunity to give the talk. So this is a joint work with Christine Courtney, Anna Duenig, Astrid Danef, Maddalena Georgescu. So let me fix a little bit the notation. So here for all my talk, G is a second countable. Like this. Locally compact. Has of groupoid. G0 will denote the unispace. R will be the range map. And that will be the source. I will also want my groupoid to be étal. So, which means that the range map is a local homomorphism. This will also imply that the source is a local homomorphism. Now, it's a result of Anataran de la Roche and Renaud that the group Sussar algebra or G is nuclear if and only if G is amenable.
Would you mind trying a different piece of chart?
Sure. You don't like this one? What did it do to you?
Some chart is very finished.
Okay. What's the problem that we are having? I am writing too light, too... Okay. And it's instead the result of two that if G is amenable, then the groupoid sister algebra is satisfy the UCT. And here we can fit, because the group is amenable, we can think that it's the full groupoid sister algebra or the reduced one. So in view of the Helio classification program that Chris mentioned, a natural question to ask is, what about the nuclear dimension? And this question was answered by Gunther, Willett, and you, that in a paper in 2017, they gave an upper bound for the nuclear dimension of the reduced groupoid sister algebra using the dynamic asymptotic dimension of the groupoid. So let me tell you what is this dynamic asymptotic dimension. So G as dynamic asymptotic dimension B, if B is the smallest non-negative integer with the following property. So for every open pre-compact set K of G, there exists, and we can assume to make life a little bit simple, that K is equal to its inverse. There exists open set. So D plus 1 open set in the unit space of G, which that cover the range of K, which is the same than the source, such that the subgroupoid generated such that, I should say, for all I from 0 to D, the subgroupoid generated by the element of K such that the range and the source are in UI is pre-compact. Okay. So let me give you a couple of various examples of dynamic asymptotic dimension. So if G is the unit space, just the unit space, then of course the dynamic asymptotic dimension of G is 0. And in reality, the dynamic asymptotic dimension of the groupoid is 0. If and only if G is locally finite, which means that it's a union of open pre-compact subgroupoid of G. Okay, now the result that Gunther Willett and you show the paper is that for G's principal, apart that all that hypothesis there, let D be the dynamic asymptotic dimension of G, and N be the covering dimension of the unit space of G. Then the nuclear dimension of the reduced groupoid sister algebra can be bounded by this number that depend only from the asymptotic dimension, dynamic asymptotic dimension D, and the covering dimension of the unit space. So in particular, if the dynamic asymptotic dimension of G is 0, and the covering dimension of the unit space is also G 0, then the reduced groupoid sister algebra is AF. Moreover, I should mention that from the proof of one that will attend you, one can see that if G is principal and has a finite dynamic asymptotic dimension, then the sister algebra must be nuclear. So G must be amenable.
Or other
What?
that it's amenable.
It's a concept. So if G is principal and it has finite dynamic asymptotic dimension, then G is amenable.
But the way you prove that is just by saying that because this theorem is nuclear, and we know that nuclear.
No, without, I am saying without this condition. So in the proof you get that the sister algebra is nuclear, even without any condition, the covering dimension of the unit space.
I mean, is that like the proof has to pass for the algebra? You can't just, it's not a group like a groupoid proof.
No, yes, it's a, yes, you show that the sister algebra is nuclear. Okay, so.
All you know is that the groupoid is amenable. Does that imply it's C-star algebra is nuclear?
Sorry?
Yes.
All you know is that the groupoid is amenable. Does that imply the C-star algebra?
Yes. Yeah, this is the result of 2. That if the groupoid is amenable, then the sister algebra is nuclear. Okay, so couple of things.
Conversation. If the full and reduced groupoid are the same, or if the groupoid that C-star algebra is nuclear, does that imply the groupoid is amenable?
No. Sorry. Yes, sorry. This is a no if and only if. Sorry, yes, sorry. I was thinking the UCT, sorry. No, the UCT go only one way, but the nuclearity, it's an if and only if. Yes. Okay, now
Okay, so that's
the UCT, it's only in one direction. If it's amenable, so then you get that is satisfied the UCT. But between nuclearity and amenability of the group is an if and only if.
what about,
Of the groupoid, sorry, it's an if.
what about map from reduced to full being isomorphism? Does that imply amenability?
I mean, nuclear means that the reduced solstice algebra is the same. Yes. So here, okay. if the group is amenable, it's the same than saying that this sister algebra is nuclear, which is the same than say also that the reduced group of sister algebra is nuclear and that they are the same. It's equivalent to say that the group, yes, yes. Can I go on? Okay, sorry. Okay, so before I want to say why we were interested in the case of the twisted group of sister algebra. I want to mention one property that this dynamic asymptotic dimension has. So first one can ask how this dynamic asymptotic dimension behave with respect to taking subgroupoid quotient. And the one result that we were able to show is that if, okay, so let H be a subgroupoid of G, suppose either H is close or there exists an open set U inside the unit space such that H has the form made of the element of G such that the range and the source are in U, then the dynamic asymptotic dimension of H is less or equal than the dynamic asymptotic dimension of G. Okay, so now what we were wondering if a result like the one that Willett and you got for the groupoid sister, reduced groupoid sister algebra could also be obtained for the reduced twisted groupoid sister algebra. And this was motivated by the work on Lee, where it showed that every classifiable sister algebra has a model as a reduced twisted groupoid sister algebra. So Lin has shown that every separable simple unital infinite dimensional sister algebra which has finite nuclear dimension and satisfy the UCT is isomorphic to a reduced twisted groupoid sister algebra. And I will explain in a few minutes what these things are. The twists that appear here are over second countable, locally compact Hausdorff et al. And effective groupoids. Here, effective means so that when we take the isotropy group, so these are the elements of G that have range equal to the source. Then the interior of the isotropy group is just the unit space. This means to be effective. Okay. Now, note that the reduced twisted groupoid sister algebra is simple. Should say assume G is effective. Simple if and only if G is minima, which means that for every element in the unit space is orbits is dense in the unit space. Now, moreover, Barlach and Lee have shown in 2020. And oh, I should have wrote. This is a theorem from Lee from, oh, sorry, this is 2020, and this is, I think, 2017. That if the reduced twisted groupoid sister algebra is nuclear, then it satisfies the UCT. So again, we want to see when this object has finite nuclear dimension for the classification program. Now, before in telling you what the theorem we got is, let me tell you what this twist and this twisted groupoid sister algebra are. So, a twist over G is consists of a locally compact as of groupoid and groupoid homomorphism I and pi, such that pi go from this to E and pi go from E to G. So such that this is a central extension. And by this, we mean that, okay, we want I to be a homomorphism onto the inverse image of G0. we want that pi is continuous, open, and subjective. Actually, I can leave this. And the centrality means that if we take I array Z E, it's the same than E I S C Z. This is the centrality condition. Now the reduced groupoid sister algebra is defined in the following way. So we can define an action of the unit circle on E. So it's defined by Z time E will be given by this condition here. And because I is injective, this is actually a free action. Okay, now that CCEG is the space of function defined on E, which have a compact support, and satisfy the relation that f of Z time E is Z over 3. Now, this is ideal, it's a close ideal of CCE, where here the multiplication is given by convolution. And if we complete this with respect to the norm, to the reduced norm, we get the reduced groupoid sister algebra. So CR star EG is a direct summand of the group, reduced groupoid sister algebra obtained by completing this idea. Okay. Now the result that we were able to show that GB principal. Oh. Oh, I didn't say before. Principal means that the isotropy group is just the unit space. Let E I pi be a twist over G. Assume that G has dynamic asymptotic dimension D, and I want to leave that on for the moment. Okay. No, I need this as well. And need this, answer this. And the covering dimension, the unit space gain is n. Then the nuclear dimension of the reduced groupoid, twisted groupoid sister algebra can again be bounded. And the upper bound is exactly the same than we had for the reduced groupoid sister algebra. Nothing. Yeah, we thought that it would get a little bigger, doesn't it? Okay, so now for the rest of the time, which I don't know exactly how much it is, is
Shorter than 20, so. Or 10.
so another 18 minutes. Yeah. So I will say a little bit about how you prove.
Ask a quick question.
Sure.
So in both, in that theorem and in yours, you say principle. Have you thought, can you replace principle with topologically principle?
Actually, Kangley has just got a result when they remove the hypothesis of being principle.
Oh, at all, like, it doesn't matter.
Yeah.
That makes sense.
It just came out.
No, you still need all the other adjectives, but not defending.
And here you don't need effective. It's only it's a color that you need, and but you don't need effective. You want I mean, when you want simplicity and free.
Same as the one.
Okay. So first we reduce to the case where the reduced twisted groupoid sister algebra is unital. Okay. Then using the dynamic asymptotic dimension of the groupoid, we construct a family of, say, nice subalgebras of I would say a little bit later what I mean by nice. I don't want to ruin the surprise. And 3, we show that this thing here is locally subhomogeneous. As defined by Elliot, New, go and this 2012, do I have the right here? Yes.
What's the question?
Is this paper the right year?
That paper,
From 2020.
well, it was published relatively recently.
Okay. I know the preprint is two.
Preprint is quite a long time.
Okay. think that it was published in 2020, but I wouldn't bet my life on it.
Okay, the actual publication was just a few years ago.
2020 is a few years
Yeah, I
ago.
didn't hear what you said. I didn't hear what you said that. Can't-
Yeah, no, I was asking if the year was correct, 2020. Okay.
Well, that sounds about right, yeah.
Thank you. Okay, so now let me explain a little bit what we do for each of the steps. So to reduce to the case where the twisted groupoid sister algebra is unital, we look at the one-point compactification of the unispace. So to assume that G0 is not compact. That G0 plus be the one-point compactification. Okay, now take G tilde as G, and we join this point here that give the one-point compactification of the unispace. This is equal to one-point compactification. So it stands R and S to G tilde by saying that the only point that has ranges source infinity is infinity itself. And the topology, so the basis of topology on G tilde consists of G tilde, the open sets of G0 plus and the open sets of G. Okay. Now with this, we get that G tilde is a locally compact Hausdorff a Thailand with second countable before we start with something second countable, a groupoid with compact unispace and the dynamic asymptotic dimension of G tilde is the same than the dynamic asymptotic dimension of the space you start with. So it doesn't change the dynamic asymptotic dimension. Yeah. Okay. So I add a twist over G. From that, now I want to construct a twist over GT. And I should mention that this Alexandra groupoid has appeared before in the work of Matthew. Him, Lee, Sven, and Dan. And they look at the essential group of the sister algebra. Yes.
To find three. Step three, I suppose, means concluding that it's locally subhomogeneous, but then you need to know that it's as finite nuclear dimension. But that's, so which step is that?
So this one is just the first step. So how to reduce to the unital case. So we want to reduce to the case where G0 is compact, so and you have a unit.
Then it's, then you know
It's just I want a unital sister algebra.
so it's fixed.
No, then I will show that yes, finite nuclear dimension. I need all three steps to show that yes, finite nuclear dimension. So I am telling you how you accomplish each of the three steps. So first you want to reduce to the unital case. Then I will build inside this reduced twisted group of sister algebra a bunch of subalgebras, which will be subhomogeneous. And then using this subalgebra, I will show what is the finite nuclear dimension of this thing. Each of these will have finite nuclear dimension, and the nuclear dimension of this sister algebra will be uniformly bounded.
Are these simple? These are not simple.
Not necessary.
Okay, but then the Venters result that finite nuclear dimension implies Yang-Su stable. That's not in the simple case.
Yeah, for this I say finite nuclear dimension. I never talked about being Yang-Su stable. I am going to show that yes, finite nuclear dimension. I am not going to show you that yes, it's Z stable. Yeah. Yeah.
It's just to apply the paper with.
I mean, it would be simple if the groupoid is amenable and effective, but
Just
not.
step three, hypothesis is not finite nuclear dimension, it's Yang-Su stable.
No, I am only saying that the sister algebra is locally subhomogeneous. So what I'm saying is that for every finite set F, and for every epsilon bigger than 0, we can find C subhomogeneous.
Finding your definition of something.
Yes, I am going to show that this sister algebra is locally subhomogeneous.
Okay, but how does that paper with 4 authors come in?
I am just referring to your definition locally subhomogeneous, where you introduce locally subhomogeneous.
But that-
Okay.
But I see the fact that it's local, so local subhomogeneous is proved by hand, and then that is used to show finite nuclear dimension,
Yes.
well,
not the other way around.
That's what we show. Well, our paper shows that. That's,
Yes.
the conclusion is finite nuclear dimension. All right. No. Well, actually, it has finite decomposition. Right?
Yeah, you are a decomposition rank, but that is such that.
Sorry, I wasn't asking for repetition of that.
Okay, sorry. So
Hope you're gonna write those four authors in again.
okay. Okay, now let me, I didn't say yet what the twist is. Okay. Okay, so now we will start with the twist. Now I want to build a twist over G tilde. So that E tilde will be E. Now we need to add a point for each value Z in the unit circle. Now the unit space of this thing would be the same than the unit space G0, G tilde. We want to extend I and pi. So we want to get G tilde 0 from here, E tilde, E tilde, G tilde. So I will need to define E tilde on infinity Z. This would be this point here. I tilde on infinity Z will be infinity. Okay. And I need the topology. E tilde is defined to make I tilde continuous and open on this image. And I tilde continuous and open. And if you do everything carefully, so E tilde, I tilde, pi tilde is a twist over G tilde. Right. You need this. So first of all, by passing from E to G to E tilde G tilde, can assume that this sister algebra is unita. And the unit space is compact. Now I want to show that this has finite nuclear dimension. So I need to start with a finite set in here and epsilon bigger than 0. So start with F, and I can take F in, like, erase it, probably, was this CCEG. The space that then you were completing to get this thing here. And epsilon bigger than 0. Okay, so you can find K compact with the support of F is containing K for all the F in this finite set. And we want to make our life simple. Let's assume that K is got to inverse. And we can also assume, if you want, that they contain the unit space. Okay. Now, so we have a K inside D. I want to use pi to get a compact set in G. Now G is locally compact, so we can find open and pre-compact. Such that IOK is containing D. And again, we can assume that V is equal to the inverse, and if you want that contain the unit space. Okay. Now, use the fact that G has a dynamic asymptotic dimension D to find U0, UD that cover a range of V, which actually will be G0 in this case, such that the subgroupoid generated is pre-compact. Okay. And I want to get also something that is open. Okay. Now, because HI is open, it will be étal, and it will also be principal, if G is principal. And so now let's look at Fi, so which is the inverse image of Hi. So this is a twist over Hi. So you can form a reduced twisted groupoid syzygy of Fi Hi. So this is our family of subalgebra. And these subalgebra are subhomogeneous. And we can explicitly describe its primitive ideal space. I am over time, all right? I am almost done. Okay, so need bigger chart. So G, H is principal. and al. And with an open cover of M bisections. In this case, you have, because your space is pre-compact and al. Let F be twist over H, then H is amenable. The primitive ideal space of the groupoid sister algebra is the RB space is subhomogeneous and last, the nuclear dimension of the sister algebra is bounded by the covering dimension of the unit space. Okay. Now let's put everything together. So in our case, this algebra here are all subhomogeneous, and they are a covering dimension that you can bound with the covering dimension of the unit space. But because G0 is metriizable, this is less than the covering dimension of the unit space. So G, so they have a uniform bound. And now we put everything together. So a unit of sister algebra. And X is subset of A. The and the none. Suppose that for all F next and so bigger than 0. Suppose that for all I from 1 to B, there exists subalgebra PI in A with a uniform bound on the nuclear dimension. And PI with normal one, such that pi f pi star is contained in bi, and two pi x pi star minus x is less than epsilon. Then the nuclear dimension of A is bounded by A plus 1 n plus 1 minus 1. So I give you the nuclear dimension of the whole sister algebra. Okay, thank you so much. Sorry I went over time.